Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss complex numbers and quadratic equations. Okay, my dear children, are you ready to listen the class? Right. In the previous class, we have discussed the concepts of complex numbers. Okay, my children, by using that knowledge, we solve the questions in exercise 5.1. Okay, my children, see page number 103, page number 103. Question number 1. See the question number 1. Express 5i into minus 3 by 5i in the form of a plus ib. Understood this question, my dear children? We have to express this expression in the form of a plus ib. You know, this is the standard form of a complex number in which there are two parts. This first one is said to be first part is said to be real part, and the second part is called imaginary part. Every complex number have two parts, namely real part and imaginary part. Okay, my dear children? Right. See here, come to the solution part. Let us take the given expression 5i into minus 3 by 5i is equal to, we use here the properties of real numbers. As we are multiplying the numbers in the system of real numbers, the same properties can be used here. So 5 into minus 3 by 5 into I into I. Understood this step, my children? Right. Here 5 gets cancelled. Finally, what will you get here? Minus 3. Understood this part, my children? Into I. What will you get here? I square. Understood this part, my children? Understood this step, my children? Minus 3 into I square. Right. That is equal to, we write this first factor as it is minus 3 into, what is the value of I square? Previously, I told you throughout this chapter, you should remember the value of I square is equal to minus 1. So, we wrote minus 1 because I square is equal to minus 1. Understood this step, my children? Right. That is equal to minus 3 into minus 1. What will you get here? 3. Finally, we get a number that is 3 only. But we should write this final result in the form of a plus ib. Is it imaginary part or real part? Yes. There is no I. So, it is the real part only. So, we write this number as a plus ib or a plus bi, where a is equal to 3 and b is equal to 0. 3 plus 0 I. Can we write it or not, my children? Automatically this term is 0. 0 into I, 0 only. But for our convenient to write this number in the form of a plus ib, we wrote 3 plus 0i, which is in the form of a plus bi, where a is equal to 3 and b is equal to 0. Understood, my children? Right. Now come to the question number 2. Question number 2. Express I power 9 plus I power 19 in the form of a plus ib. Here also an expression is given. We have to write it in the form of a plus ib. Understood this question, my dear children? Right. Come to the solution part. Let us write the given expression, that is I power 9 plus I power 19 is equal to, let us write the value of a first term. What is the first term here? I power 9. The power, what is there? 9. We have discussed the powers of I. When we are discussing the powers of I, if the power of I is more than 4, if the power of I is more than 4, we have to divide that number by 4. See here in the rough work, I have done the part. We have divided that 9 by 4. Then what is the remainder here? 1. So we should write 1. In the place of 9, we can write directly 1. Understood the part, my dear children? First term, right. Now come to the second term. We follow the same rule here also, because the power of I is more than 4. So immediately we have to divide that number by 4. 4 fours are 16. What is the remainder? This remainder should be written as the power of I. Okay, my dear children, understood the second term, my dear children? Right. Because I power 9 is equal to I power 8 into 1. It is a multiple of 4. So its value is 1. If the power of I is a multiple of 4, if the power of I is a multiple of 4, then its value is 1. Remember this point, my children. 1 into I, we get I only. Similarly here, I power 19 can be written as I power 16 into I cube. Here also 16 is a multiple of 4. So its value is automatically 1 into I cube. We get I cube only. Understood these two results, my dear children? Right. Understood this step, my dear children? Right. That is equal to I power 1. What is the value of I power 1? I only. Plus I cube. We have discussed that point. I cube can be written as I square into I. What is the value of I square? Minus 1. So minus 1 into I, minus I. Understood this second term, my dear children? Right. That is equal to, by simplifying these two numbers, I plus minus I, these two terms gets cancelled. No term will be left. So 0. We get here 0. After simplification, finally we got 0. How can you write in the form of a plus ib? Here we can write 0 as 0 plus 0i. Isn't it or not, my children? Can we write this number in this form or not? Yes, which is in the form of a plus ib, where a is equal to 0, real part is 0 and imaginary part is also 0. Understood, my children? Right. Now come to the question number 3. Question number 3. Express I power minus 39 in the form of a plus ib. Understood this question, my dear children? Right. We have to express this number in the form of a plus ib. Okay. Right. Come to the solution part. Let us take the given data. What is the given data? I power minus 39. Okay, my dear children, if you observe this term, it is in the form of a power minus n. How can you write a power minus n? Yes, 1 by a power n. That is equal to 1 by I power 39. It is, since it is in the form of a power minus n, we are using this laws of exponents. You have already studied in earlier classes, in 8th class itself, laws of exponents. So by using this laws of exponents, we wrote this step where a is equal to I and n is equal to 39. Understood this part, my children? Understood this step? Right. That is equal to 1 by, if you observe the denominator, in the denominator I power 39 is there. The power of I, what is the power of I here? 39. It is more than 4. What I said, when the power of I is more than 39, immediately divide that number by 4. I have done that part in the rough work here. See that one? 4 39, we are dividing this 39 by 4. 4 nines are 36. What is the remainder? 3. This remainder should be written as power of I. Instead of 39, we can write I cube. Understood this denominator part, my children? Whatever the remainder we got here, we should write as power of I instead of the previous power. Understood this step, my children? Right. Now come to this part. I cube. What is the value of I cube? Minus I. Okay, my children. So 1 by minus I. I have written I cube value is minus I. So if you observe this one, it is a imaginary part. In the generally in the denominator, we write real part, not imaginary part. So to make this denominator as a real part, we have to multiply the numerator and denominator by its conjugate. It's a conjugate complex number. Here assume that 0 minus I, so 0 plus I means I only. Its conjugate is I only, so we are multiplying the numerator and denominator by I to make the denominator as a real number. We are doing this rationalizing. Understood this part, my children? Right. That is equal to, we take minus to the numerator, so minus 1 into I. What will you get here in the numerator? Minus I whole divided by I into I. What will you get here? I square. Understood this step, my children? Right. That is equal to, we are writing minus I as t divided by denominator. What is the denominator here? I square. What is the value of I square? Minus 1, because I square is equal to minus 1. Understood this step, my children? Right, here minus minus gets cancelled. I by 1. I by 1 can be written as I. So this is the final result after simplification. Okay, my children, understood? Now this number can be written as 0 plus I. Isn't it or not, my children? Here imaginary part is there because this is a purely imaginary. That number is a purely imaginary complex number. Real part is not there, so we can write 0. In the part of real part we can write 0 plus I, which is in the form of a plus ib, where a is equal to 0, real part is 0, and b is equal to 1, imaginary part is 1. Imaginary part is nothing but coefficient of I. In that expression, in this expression, the coefficient of I is considered as imaginary part, means b. Understood this point, my children? Right. Now come to the question number 4. Question number 4. Express 3 into 7 plus I7 plus I into 7 plus I7 in the form of a plus ib. Understood this question, my children? We have to write this expression in the form of a plus ib. Okay, my children? Right. Come to the solution part. Let us write the given expression as it is. I wrote the given expression as it is. 3 into 7 plus I7 plus I into 7 plus I7. Okay, my children. This is equal to, here there are two terms. If you observe the two terms, this is the first term plus this is the second term. For the first term as well, for the second term, we are using the distributive property. We can use the distributive property. As in the case of real numbers, we here also we can use the distributive property. Okay, my children. So 3 into 7, what will you get? 21. 3 into I7, 3 sevens are 21I. Understood the second term, my children? Right. Plus, here also we use the distributive property. I into 7, 7I. We don't write I7. In general, we write numerical part first and literal factor next, second. Okay, my children? In this order only we write. Plus I into I7. What will you write? 7I square. Understood this last term, my children? Right. By using the distributive property, we got these four terms. Okay, my children, understood this step? Right. Now 21, we write the first term as it is. See the second term and third term, these two terms are like terms. We can add like terms and subtract the like terms. Okay, my children. So 21 plus 7. 21 plus 7. What will you get here? 28I. Understood this part, my children? This understood this term? Right. Plus 7 into I square is there. What is the value of I square? Minus 1. Because I square is equal to minus 1, we wrote this part. Understood this part, my children? Understood this step, my children? Right. That is equal to 21 plus we are writing second term also as it is. We are simplifying the third term, last term. 7 into minus 1. What will you get here? Minus 7. Understood this last term, my children? Right. Understood this step, my children? Right. If you observe this step, there are three terms. This is 21 plus this is 28I and third term is minus 7. If you observe the first and last term, these two are real parts. So we can simplify like terms. They are like terms. 21 minus 7. What will you get here? 14. Plus this is imaginary part. We write as it is 28I. Understood this step, my children? Right. So we got to finally, this is the final result after simplification, which is in the form of a plus ib, where a is equal to 14, that is real part is equal to 14 and the imaginary part is 28. Remember this, my dear children. Imaginary part means coefficient of I in this complex number. Okay, my dear children? Right. Now come to the question number 8. I am not explaining the question number 5, question number 6 and question number 7 because these three questions are of the same as fourth question. Okay, my dear children. Will you try yourself these questions, my dear children? Right. Please try these questions yourself. Okay, my dear children. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children. Right. Now come to the question number 8. Question number 8. Express 1 minus I whole power 4 in the form of a plus ib. Understood this question, my children? Here also an expression is given. We have to write this expression in the form of a plus ib. Okay, my children? Right. Come to the solution part. I have written the given expression. What is the given expression? 1 minus I whole power 4. Okay, my children. So this expression can be written as 1 minus I whole square whole square. Can we write it or not, my children? Because a power mn can be written as a power m whole power m, where m is equal to 2 and n is equal to also 2. By using this laws of exponents, I wrote this step. Understood this step, my children? Right. Now, if you observe this one, it is in the form of a minus b whole square. We can use that algebraic identity where a is equal to 1 and b is equal to I. Okay, my children, by using the algebraic identity a minus b whole square, we can expand. So a square minus 2ab, a means 1, b means I told you, plus b square, whole square is there already again. Okay, my children? By using this algebraic identity a minus b whole square is equal to a square minus 2ab plus b square, we got this step. Understood this step, my children? Right. That is equal to, let us simplify these three terms in this square brackets. What is the first term? 1 square. What is the value of 1 square? 1. Understood this first term, my children? Right. Now come to the second term, minus 2 into 1 into I. What will you get after simplification? Second term, minus 2i. Understood this is second term, my dear children? Right. Plus, come to the third term. What is the third term? I whole square. What is the value of I square? Minus 1. So we wrote minus 1. Third term value is minus 1. Understood this third term, my dear children? Right. Whole square is there. We wrote whole square as it is because I square value is minus 1. Understood this step, my dear children? Right. Now let us simplify the terms in this square brackets. Here first term is 1 and the last term is minus 1. These two terms gets cancelled. These two terms are real parts. Okay, my children? So these two terms will get cancelled. Then what will the term left here? Minus 2i. Understood this step, my children? Whole square is there. Minus 2i whole square. Understood this step, my children? Right. What is the value of minus 2i whole square? Minus 2 whole square. What will you get here? 4i square. Understood, my children? Because by using the laws of exponents, ab whole power n is equal to a power n into b power n. Here a means minus 2 into b means I, n means 2. By using that law. So minus 2i whole square, this can be written as minus 2 whole square into I square. By using this laws of exponents, ab whole power n is equal to a power n into b power n. So minus 2 whole square, what is the value of minus 2 whole square? I wrote the value of that number directly here for I square. Understood this step, my children? Right. That is equal to 4 into, what is the value of I square? Minus 1. Since I square is equal to minus 1, we used that result here. Understood this step, my children? Right. That is equal to 4 into minus 1. What will you get here? Minus 4. Okay, my children? Now, this number can be written as minus 4 plus 0i. Can we write this number in this form or not, my children? Yes. Which is in the form of a plus ib, where a is equal to minus 4 and b is equal to 0. Understood, my children? Right. Now come to the question number 11. Question number 11. Here I am not explaining the question number 9 and question number 10. Try yourself these questions, my dear children, because 9th question and 10th question are in the form of a plus b whole cube. Use the algebraic identity a plus b whole cube and simplify it and write the final answer in the form of a plus ib. Will you try these two questions, my dear children? Right. Now come to the question number 11. If you have any doubt in solving the question number 9 and 10, ask your doubts and get your doubts clarified. Okay, my dear children? Right. Now come to the question number 11. Find the multiplicative inverse of 4 minus 3i. Understood this question, my children? We have to find the multiplicative inverse of this number. Okay, my children? You have to recall the previous knowledge. You have already studied. You have already learnt the multiplicative inverse of a number. Suppose a is a given number, then what is the multiplicative inverse of a? Yes, 1 by a is said to be multiplicative inverse of a. So here this is a given number 4 minus 3i, then its multiplicative inverse is 1 by 4 minus 3i. Understood this step, my children? That is why I wrote multiplicative inverse of 4 minus 3i is equal to 1 by 4 minus 3i. Understood this step, my children? Right. We got this number, but this is not in the standard form of a complex number. What is the standard form of a complex number, my children? Yes, a plus ib. Every complex number should be written in that form only. But here it is not in the form of a plus ib. So we had to make it into the form of a plus ib. So if you observe the denominator, this is a complex number 4 minus 3i. To make this number in the denominator, complex number is there. We should make it every time as a real number. Remember this point, my children. So to make this complex number as a real number, we have to multiply the numerator and denominator of this fraction by its conjugate. It's a conjugate complex number. What is meant by conjugate complex number? Just to change the sign of imaginary part. Here minus sign is there. Just to write plus. Then we get the conjugate of this complex number. So what is the conjugate of this complex number? 4 minus 3i. Yes, 4 plus 3i is the conjugate of this complex number. So we are multiplying the numerator and denominator by its conjugate. Complex number is 4 plus 3i. Understood this step, my children? Right. Now we multiply numerator and denominator. Then what will you get? 1 into 4 plus 3i. 4 plus 3i only in the numerator. Understood the numerator, my children? Right. By come to the denominator, if you observe the denominator, it is in the form of a minus b into a plus b, or a plus b into a minus b. Then immediately you have to recollect. You have to recall the previous knowledge of algebraic identity. A plus b into a minus b is equal to a square minus b square. So where a is equal to 4 and b is equal to 3i. Okay, my children, we apply this algebraic identity to the denominator. Then what will you get here? 4 square minus 3i whole square. Understood this denominator, my children? By applying this algebraic identity, a plus b into a minus b is equal to a square minus b square, we got to the denominator. Understood this step, my children? Right. Now come to the next step. Numerator, we are writing numerator as it is. By we are simplifying the denominator. What is the value of 4 square? 16 minus, come to the second term in the denominator, 3i whole square. It is in the form of ab whole power n, where a is equal to 3 and b is equal to I. So we can use this laws of exponents. Ab whole power n is equal to a power n into b power n, means 3 square. What you get? 3 square value 9 into b power n means I square. So we get second term minus 9 I square. Understood this second term in the denominator, my children? Right. Understood this step, my children? Right. That is equal to, we write numerator as it is 4 plus 3i divided by, come to the denominator, we write the first term as it is 16 minus 9 into, what is the value of I square? Minus 1. Since I square is equal to minus 1, we are substituting this value in the place of I square. Understood this part, my children, in the denominator? Right. Understood this step, my children? Right. That is equal to 4 plus 3i by, come to the denominator, 16 minus 9 into minus 1. What will you get here? Plus 9. Understood the denominator, my children? Right. That is equal to 4 plus 3i by simplifying the denominator we get 25. Understood this step, my children? Right. Now we are splitting this entire number into two fractions. Can we split into two fractions or not, my dear children? Right. Yes. 4 by 25 plus 3 by 25i. Okay, my dear children? Right. We splitted this entire number into two fractions like this, which is in the form of a plus ib, where a is equal to 4 by 25, this is the real part, and 3 by 25i, this is the imaginary part. Understood, my dear children? We wrote the given complex number in the standard form, that is a plus ib. Understood, my dear children? Right. Now come to the question number 14. Here I am not explaining the question number 12 and question number 13, because question number 12 and question number 13 is of the same as question number 11, multiplicative inverse, finding the multiplicative inverse. Will you try yourself these two questions also, my dear children? Question number 12 and question number 13. Right. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my children. Now come to the question number 14. Question number 14. Express 3 plus I root 5 into 3 minus I root 5 whole divided by root 2 plus root 2i minus of root 3 minus I root 2 in the form of a plus ib. We have to write this entire expression in the form of a plus ib. Understood this question, my dear children? Right. Let us take the given expression, that is 3 plus I root 5 into 3 minus I root 5 whole divided by root 3 plus root 2i minus of root 3 minus I root 2. Okay, my dear children. Now let us simplify numerator as well as in the denominator step by step. Okay, my dear children. Right. That is equal to, if you now come to the numerator, if you observe these expressions, they are in the form of a plus b into a minus b. Then can we use the algebraic identity a plus b into a minus b is equal to a square minus b square, my dear children, for the numerator? Yes, we can use that algebraic identity. So where a is equal to 3 and b is equal to I root 5. So we use it here 3 square minus I root 5 whole square. Understood numerator, my dear children? Right. Now come to the denominator. Here we are removing the small brackets. So root 3 plus root 2i. We wrote these first two terms as it is. Minus of this expression is there. So we change the sign of each and every term. So minus root 3 plus I root 2. Understood this denominator, my dear children? Right. Because a plus b into a minus b is equal to a square minus b square. We used this algebraic identity for the numerator. To get this step, we used this algebraic identity. Understood this step, my children? Right. That is equal to, now come to the numerator, 3 square. What is the value of 3 square? 9 minus I root 5 whole square. It is in the form of a b whole power n, where a is equal to I and b is equal to root 5. So root 5 whole square, what will you get? 5 only. I wrote directly. Root 5 whole square value is 5 into I square, because ab whole power n is equal to a power n into b power n. By using this laws of exponents, we got this second term. Understood the second term, my children, in the numerator? Right. Divided by, come to the denominator here, root 3 is there. Here minus root 3 also there. So these two terms gets cancelled. Then what will the terms will be left here? Root 2i plus I root 2. Both are like terms. So we get 2 root 2i, because we can add these two like terms. Okay, my children. Understood this denominator, my children? Right. Understood this step, my children? Right. That is equal to, come to the numerator, 9 minus 5 into, what is the value of I square? Minus 1. Understood this part, my children? We wrote I square value here, whole divided by 2 root 2i. Understood this step, my children? Because I square value is minus 1. By using this result, we wrote this part. Understood this step, my children? Right. That is equal to 9. What will you get? Minus of minus 1. Minus of minus plus 5 into 1, 5. Understood numerator, my dear children? Right. Whole divided by 2 root 2i. Understood this step, my children? Right. If you observe in this step, if you observe the numerator and denominator, in the numerator we get a real part. 9 plus 5 is 14. But in the denominator, it is imaginary part is there. We have to make it as a real part. Okay, my children? Right. To make this denominator as rational number, we are multiplying the numerator and denominator by its rationalizing factor. So for 2 root 2i, here irrational number is root 2. So we multiply root 2. Okay, my children, numerator and denominator by root 2i, because I is also there. To make this rational real number, we multiply the numerator and denominator by I. So finally, the rationalizing factor of 2 root 2i is root 2i only. No need to take again 2, because already it is a real part, real number. Okay, rational number. No need to take this part, root 2i. So it's a rationalizing factor is root 2i only. So we are multiplying the numerator and denominator by root 2i. Understood this step, my children? You have to identify what is the rationalizing factor of the given number. So here 2 root 2i is there, but its rationalizing factor is root 2i only. Okay, my children? Right. That is equal to, we multiply the numerators 14 root 2i. Understood numerator, my children? By, we multiply the denominator 2 into root 2 into root 2 whole square, I into I square. Understood this denominator, my children? Right. That is equal to, we write numerator as it is 14 root 2i by 2 into root 2 whole square. What is the value of root 2 whole square? 2 only. Into, what is the value of I square? Minus 1. Because I square value is minus 1. Understood the denominator, my children? Right. Understood this step, my children? Right. That is equal to, we bring minus 1 to the numerator. So minus 14 root 2i by, then what will you get in the denominator? 2 into 2, 4. Understood this step, my children? Right. Now we cancel the numerator and denominator by 2 table. So 2 2s are 2 7s are. What will you get in the numerator? Minus 7 root 2 by, what will you get in the denominator? 2i. Okay, my children? This is a final number. After simplification, we get a final result of this number. Can we write this number as 0 plus minus 7 root 2 by 2i? Yes, we can write it, because here real part is not there. So we wrote 0 as per our convenient. Okay, my children? Now if you observe this number, it is in the form of a plus ib, which is in the form of a plus ib, where a is equal to 0, real part is 0, and b is equal to, that is imaginary part is minus 7 root 2 by 2. Understood, my children? Right.